All right, good afternoon. My name is Carmelo Iaria. I'm a founder and CEO of the AI Academy. I'm not going to spend too much time on this because you heard an introduction from Siri. Just to give you a little bit of a context. The project that we chose is about 2018 Brazilian presidential election. And in this chart, we try to show the difference, what happened between 2014 on the left and 2018 to the right. This is really just to give you a little bit of a context for those who haven't followed the elections in Brazil. But it was a pretty dramatic shift politically. On the left, you have the winner. It was the Workers' Party representative in red. They won the election. And the Worker Party was represented by another person on the right that lost the election. So there was a shift. But you can see in this chart something pretty interesting. You can see that the difference, the intensity of the colors, they kind of show how tight the fight, the competition was in 2014 compared to 2018. If I'm not mistaken, I think there was only maybe about 3 to 4 million votes difference in 2014 between the winner and the loser. On the right, 2018, it was October last year, there was over 10 million votes of difference. So this is just to give you a little bit of a context, but the project was about understanding how the politicians were running the campaigns. And so for that, we selected 2 use cases. One is about identifying the ideological position of the programs they were presenting. And the second one, understanding how they competed, what we call the media war, how they try to take a leadership position both on television debates and on social media. And so it was interesting that we had to deal with a lot of data, with a lot of text. And there are several tools that we've been using. One of them was Driverless AI. We're going to show how we did that. And it's interesting because not all the tools are available or give you the same results for all the languages. And since we had to deal with Brazilian Portuguese, it was quite exciting to try to build our own sentiment analysis classifier using the Driverless AI product. So just go quickly to the first use case. It's a little bit of a snapshot of what the data sources were. We had 13 political programs. And we had analyzed the political programs across 6 dimensions, policy dimensions, from economy, education, external policy, political system corruption, human rights, and safety. What we decided to do is to extract some information from the text and code it visually to create some visualization to represent the ideological position of the different parties. And so we, on one side, we did a pretty simple score of the weight of how much a specific policy was important, how important it was in the overall program. But then we used some more advanced unsupervised learning technique to detect and measure the political, the ideological position from the political spectrum. So here we have a little bit of a text about one of the techniques. So there are links to the papers that describe these techniques. In this specific case, it's a paper that some scientists used, I think back in 2007, to analyze German political parties' shift in ideological positions. And so we did the same. We applied similar techniques to identify this across the 6 policies that we identified there. What's nice about this technique is it's language independent. So it was very easy to apply also for Brazilian Portuguese. And it's an unsupervised technique. So we did not have to tell or teach the model what was right, what was left. The technique that we used was unsupervised. And so the relative position of the different programs was extracted automatically from with this model. The model is also available as an R library, so it can be used for the exercises. And it provides a relative position. So essentially, it does frequency count, word frequencies, analysis, and it really tries to see the relative position of one political program in a specific policy compared to the other. Just to give you the visual, I did extracted an example. These are 3 of the 6 policies that we talked about. And you can see here that these are the representative of each of all the 13 programs that run in the first term. And we have coded the size of the bubble as the relative importance of that particular policy in the program. The other thing that we coded is a little bit the ideological position left to right relatively to the rest of the corpus. And so you can see a couple of things you can notice here, and there's more in the links to the actual visualization. But you can see, for example, just by looking at the image, that human rights and social welfare, the middle policy there, has a very distinct pattern. You see the rightmost position have a very small bubble, which means they had very few words, very few emphasis on the specific topic. And they're very extreme. You can see the position on the x-axis. On the left, the position were a lot more bigger. The bubbles were bigger, but also were kind of clustered in a similar position, right? I think it's also wise to recognize that economy and employment was pretty much a key topic across the programs. There is a little bit of difference from on an ideological position standpoint, but everybody really put a lot of emphasis because it was a key topic for the electorate in Brazil. It's an interactive visualization. We use a framework called the D3.js to build this interactive visualization. And if you go to the link, you can actually click on each of them, each of the bubbles. You can actually see a summary. For example, this is the winning candidate, and this is a summary of the position on the external policies. And on this second page, you can kind of navigate by policy or by candidate and compare a little bit the different policies. There's a link to the interactive visualization. That was use case number 1. Use case number 2 is my favorite. It's very interesting. And we wanted to analyze a little bit of the debates, the war on the media, and comparing a little bit the traditional media, how candidates behave or express themselves in traditional media compared to social media. As happened in the United States a few years ago also, this year is probably the first time ever in Brazil that a political candidate uses social media heavily to influence the electorate. So there was a very similar dynamics that happened in the US, happening for the first time in Brazil. So it was very interesting to analyze that from that standpoint. And so what we did, we had, in terms of sources, we actually capture most of the main broadcasted television debates. We also look at the activities on Twitters of the candidates, of the political candidates. We wanted to identify what the political attacks were and compare then, again, the difference between the traditional media and the social media. So visually, we've encoded a number of things. So it's going to be clear probably in the visualization. But first of all, whether the candidate participated or not, there was one aspect to the debates. Who attacked who, the attacker, and so forth. The number of attacks and the intensity. So those all created those elements of the visual encoder that we decided to present. And again, to do that, we use a number of techniques. I'm going to talk a little bit about in a few later slides. But essentially, we tried to compare out-of-the-box solutions. Particularly, we used Google sentiment analysis APIs, or natural language APIs, and IBM Watson APIs. And then we created our own classifier using Driverless AI. From the visualization that were created by our team, again, custom visualization using D3.js framework. So to build the classifier, what happened? We had a number of experiments. So we used an experiment using three type of strategy: out-of-the-box solution, the two that I mentioned before, which is the section A. And section B is our own developed classifier built on a public data set. There is one piece of the work that we've been able to complete by the time of this event, but we're working on it. And it's actually where we're really going to expect a lot of advantages of using driverless in an iterative way. So we can actually annotate automatically a large corpus of Brazilian political text. And so this we're going to publish probably in a future stage. In terms of the classifier that we built, we did a number of experiments. Some of them were using English corpora, the first two. It was sentiment analysis, annotated corpora. One was related to the airlines. One about political social media posts data set. I think both of them are available on Kaggle, and they were provided by Cloudflower library. Now, the one that we used was actually manually annotated by some data science in Brazil of a local university, and that's the one we used. It's about 15,000 tweets that were classified with three classes: so negative, positive, neutral. And it was very nice because it was a balanced data set, so it was good representation across the different classes. It was easy to train. It was a very good quality data set to start with. We have the references in the links and at the end of the presentation as well. So here's a little bit about the experiment. So if you can make it run after my talk, SRK is going to talk about NLP in another room. So it's going to probably give you a lot more technical details about it. He's the one that wrote the recipes for NLP. But this is a nutshell, a little bit of what's happening under the hood. There is several techniques, NLP techniques happening at the same time when you run NLP on driverless. Essentially, the data set was taking one column, one feature, which was the text. And it does a number of transformations. You use a number of features like counts, TF, IDF, word embeddings, and applies different transformers, different models from regular logistic regression and linear models all the way to TensorFlow-based convolutional networks on word embeddings. And it does that to create and engineer new features, right? So in this example, we had, in our data set, we had about, I can see here there's 1,140 features were engineered by driverless. 167 of them were selected to create the model. This is just from one column of text, right? We had, I don't know if I have in these slides, but we had we were running this on a cloud instance on Amazon with about 4 GPU, 488 gig of RAM, and I think 32 virtual CPUs. It's a P2 8X large AMI or instance, EC2 instance. And so it took about 1 hour and 49 minutes to do this model, right? And so if you see the amount of feature engineering that happened, it would take even an advanced team of data science a lot of time to do the same amount of work. So this is where we see the benefits of using driverless, specifically for this type of use cases. Beside the feature engineering, which is a real core, real benefits of driverless, the model actually trained a number of models and did ensemble at the end. So you can see here is 2 XGBoost and 2 LightGBM models. And that was taken, just to predict the sentiment, which was the target variable for this. The results were interesting because we then took a specific data set to actually compare the performance of all the different models. So we have a separate test set, and we score this test sets using both the Google API, the IBM Watson, and our model. And you can see here that there's a specific, the F1 score is the metric that we use. It's a good metric to take into account a little bit of balance between precision, accuracy, recall, all the different performance metrics of a confusion metrics. And these are the numbers. So you can see that for the negative, we did pretty much the same as Watson. For the neutral sentiment, the positive the results were better. I think we attribute this a little bit about to the fact that was especially the feature engineering work that happened and the specific work that was done on this Portuguese-speaking data set. It was tailor-made for, it was trained on a specific Brazilian Portuguese data set. So it's very encouraging. We definitely want to improve on that. This is why next step, like I mentioned before, will be to annotate a larger corpus and try to see if we can improve the performance using the same technique. Now, in terms of the results, we did the visualizations. Actually, taking inspiration of a paper of an article that was presented in the New York Times in 2007. And they were presenting mentions. So we've taken that approach and took a step forward. And so we had to actually to detect the mentions in the text and then do sentiment analysis on it to sort of identify the attacks from one candidate to the other, essentially. And so you can see here that there's different segments. On the circle, you have the different candidates. There's in this particular visualization is about the TV debates. And so there were multiple TV debates. In the interactive visualization, you can actually filter and select each debate and identify patterns, of behaviors of the candidates during the debates. So the lines are attacks. The ones that I think there's a zoom in. The ones that go in the middle of the segment are the attacks to the candidate. The other ones are the attacks the candidates those to the others. We also able to, with this visualization, was done by the team in the D3.js. You can actually select each attack, and you can actually see the text and see what was the attack about, right? Here a little bit of some samples. This is the winning candidate. What's interesting about him is that you can see there are only two segments. He did not participate in the TV debates. There was an accident. He was stabbed during the campaign, and he couldn't participate to some of the TV debates. But nevertheless, received a lot of attacks from everybody else during the campaign. And he did relatively few attacks himself when he was at the debate. So this is one of the things that we can extract, from this visualization. Probably my favorite one is actually when we put together side by side the TV debates attacks and the attacks on Twitter, because Bolsonaro has been following, very much like Trump in U.S. Done a lot of activity on Twitter and on social media. So he did not participate in the TV debates, but he was definitely active on social media. And it was interesting to see this, because you can see quite dramatic difference in the patterns and the visualization. On the right, you have the Twitter attacks, and the two where there's a majority of the attacks back and forth are the two that went to the second turn, right? The one in the red lost, and Bolsonaro won. And it's interesting to see that the other candidates are pretty much not active at the same time, right? So there's a lot of things you can read into the visualization. I'm going to maybe click into the actual visualization interactive parts to the end, just to finish up the presentation. Just want to show a little bit of conclusions. first of all, doing NLP projects in non-English speaking language presents a number of additional challenges on top of the challenge that everybody else has got. We saw that there's, out-of-the-box solutions are pretty powerful. They're very flexible. But sometimes you need to do a custom job and do your own sentiment analysis, and you can get better results. For that, we used Driverless AI, and it was pretty efficient the way we did the sentiment analysis classification, and that gave us a lot of time to think about the product and the process overall, the visualization, and what, from a business standpoint, we would take out of the exercise. I want to mention the team just briefly. This is the team that worked on the project. We see Driverless as part of the team. That's just one of the data science that's been working with us. And then I have some references here for those who you want to read some more about this. I don't know if I have time to go to the interactive visualization or not. It's over. I'm just going to briefly. Yeah, I guess I need to stop this. No. Yeah, I guess this is just quickly to see the tool dynamically work, right? So we can select. These are the different TV debates. We can actually see the attacks received by a candidate. We can filter those. And then here we have the Twitter debates. Similar visualization. So those are the live interactive visualization that we built. That's it. Thank you very much.